Hey guys, how's it going? Today we're going to take a look at some more area formulas. First thing we're going to do in this video is show how we come up with a formula for area of a trapezoid. So trapezoids, if you guys remember, you have two bases. Those are the parallel sides, and then you have two non-parallel sides. We call those things the legs. So our area formula is all going to be dependent on these two base lengths and also the distance between those bases. We call that thing the height. So that's a perpendicular distance. So what we're going to do is take this problem, and it's an area we haven't found before, and we're going to turn it into smaller problems that we do know how to find the areas for. It's a real common thing that we do in math. We take a new unsolved problem, divide it into smaller problems that we know how to solve, and then basically combine our solutions together. So what I'm going to do is divide this up using some perpendicular lengths there, so that's, we can call that the height. Now what I've done is I've formed two triangles then connected to a rectangle. Now they may or may not be congruent, only if this is an isosceles trapezoid. So the nice thing about this area formula is it applies to all possible kinds of trapezoids. So I'm going to go ahead and color these things blue, and I'm going to give some names to their parts there. So we know the height, that's distance between bases. That's also going to be the height of our triangles. Now the triangles each should have their own base length. I'm going to call this one x, oops, and this one y. Okay, so and this middle part's going to be a rectangle, so this is going to be base 1. I've just labeled that base 1 and base 2. Okay, so what this is telling me based on this picture is for any trapezoid, I can actually cut it, or I should say divide it into a rectangle attached to two triangles instead of just one big trapezoid. Another thing I want to point out here is this base 2. We see how long that is. Well, that's going to be the same as x plus y plus base 1. Okay, we're going to use that a little bit later. Alright, so let's look at areas. So I'm going to say triangle area. I'm going to draw that over here to the side. So those two triangles, imagine I just cut them off and then I glue them back together over here. So what that means is I'm going to have a height of h, and the base is x plus y. X plus y. Okay, so we should know this. Area equals half base times height. So half of x plus y times the height of h. So that takes care of the triangle part. Now we're going to add in the rectangle area. Let's see if I have any other colors I can use here. I think this green one might work. So rectangle area. Oh, they barely see that. So I'm going to go ahead and draw that rectangle over here to the right. So it has a height of h and a base of b1, labeled that earlier. So this area is base times height. Okay, so the total area, we're just going to combine those two things together. So total. Okay, so let's go ahead and add those together. I've got 1/2 x plus y times h plus b1 times h. Okay, so some things that they have in common. They both have an h, and that's a common factor. Remember, that's something separated by a multiplication. So one thing I'm going to do, in fact, from here on out, we're just going to use some fancy algebra to come up with our formula that's only going to have the bases and the height in it. So what I'm going to do is factor out that h. So now I have 1/2 x plus y. The h I'm taking out. And so those h's now I've just factored out. It's the opposite of distribution. Okay, so next thing I'm going to do is rewrite this as just one fraction. As I said, the rest of this is just a lot of algebra tricks. So plus base 1. And you're totally allowed to do that. 1/2 times a sum is the same as that thing divided by 2. Okay, now I need to add two things together, and those are fractions. I need a common denominator. So denominator of a 2, multiply top and bottom. So times 2 times 2. And so then I get x plus y plus 2 base 1, and all of this stuff is divided by 2, all times h. Okay, so now is the even more confusing part. I'm going to take a 2 and rewrite it as 1 plus 1. You're all saying to yourself, yeah, I know 2 is 1 plus 1. Why in the world would you do that? Well, it's going to make the formula work nice and neat here in a second. I'll show you. So instead of 2b1, I'm going to say x plus y plus b1 plus another b1, and this is all over 2 times h. Okay, so the reason why I did that, if we go back to our original picture here, if you remember, I pointed out an expression for b2. Our second base was the same as x plus y plus our first base. So if we come down here, x plus y plus our first base. Alright, so we're going to be able to do a substitution. This right here, I can instead write it as all of that. I can write b2 plus b1, and this is actually going to be our formula. All it is an average of the bases, and then you multiply by height. So another way you can write that is 1/2 b1 plus b2 times height. A lot of different ways you can express the same thing, but think of it as an average of bases, and then you multiply by height. And that's our trapezoid formula. One thing I want to point out, if you all remember, we talked about that mid-segment or median of trapezoids. We said that its length is the average of the bases. So if you remember that, you could think of this as, instead of average of base times the height, you can think of like median, or can't remember if we call it median or mid-segment, but this right here is our area formula.